Okay. Yes, question?
Okay.
Oh, I didn't give you one? Okay, so again, polar coordinate system, right? We kind of change it up. It's polar coordinate system. Instead of the origin, we now call that the pole. Instead of the x-axis, we now call that the polar axis, and it's again related to like the Earth, right? So you can imagine if you were looking at the Earth from like the bottom, a bottom view of the Earth or the top view of the Earth. You know, again, there's not really top or bottom, but it's just in how we normally used to seeing things. This is like looking at the pole. These concentric rings are like latitude, okay, and then these rays are like our longitude measurements and stuff. Okay, and so here's how we locate points in polar coordinates. So we have our pole, okay, like the origin there. We also kind of have the polar axis going out from our pole, okay, and it is from this polar axis that we measure our angles, okay. It's from this polar axis that we measure our angles. Now, what would be like the equivalent to that on the Earth, right? So from what line do we measure all the like angles and stuff?
The equator.
So the equator would be, again, a latitude line, so that'd be like these concentric circles, but I'm talking like a longitude line that we measure angles from.
The other equator.
The prime meridian, the other equator. Yes, aka prime meridian. Yes, exactly. Okay. So the prime meridian, I believe, is degree 0 longitude, and then from that we measure, other lines of longitude there. Okay. And so the polar axis is like our prime meridian, and we measure from it certain angles theta. And so we'll go to locate a point right here. So let's say we've got a point right here, not on the polar axis, and to locate it, what we'll do is we will rotate a certain angle, theta. Okay. We'll rotate a certain angle, theta, and that'll put us like at the pole. We kind of turn our orientation there from the polar axis. We'll rotate this angle, theta, so that we're now facing the point. And then we will travel a certain distance, and we'll call that distance r, as in like a radius, right? Center to edge, as in a radius, and then that'll locate our point with the coordinates r, comma, theta. Okay. For the sake of comparison, you can kind of think about you can kind of view it in this sense, right? So in rectangular coordinates, if I was trying to get from where I am right here, like let's say I'm at the origin and I want to get to like the back corner of the room, in rectangular coordinates, I would need to travel left a certain amount and then up or forward a certain amount, right? And that would get me to the back corner of the room. In polar coordinates, instead of going left and back, or forward there, whatever you want to say, instead with polar coordinates, I rotate a certain angle theta so that I'm now facing the back corner of the room, and then I will travel in that direction r, whatever the r, whatever the distance is from here to there. So again, rectangular is more like me moving left and then back or forward, back towards the back of the room there, okay? And then for polar, it's more like I turn on the pole, face the direction of the point where I want to go, and then go out that distance r. Okay? That's how we locate points in the polar coordinate system. We still need two numbers, right? So just like with rectangular coordinates, you need two numbers to locate a point in a two-dimensional space. Likewise here, we still need two numbers to locate a single point in two-dimensional space, right? And that's just the nature of the beast. So yeah. Yeah. All right, so let's locate some points. Let's actually get down to it, right? Now that I've kind of talked it to death, let's plot some points. Okay, so let's plot, for example, the point 2, comma, pi over 3. Now, when you plot in rectangular coordinates, I think most of us probably locate use the x coordinate first and then the y coordinate. Remember here, these are not x and y coordinates, okay? This is an r value, this is a theta value. And I would recommend that you first locate theta Okay, locate theta first. I almost said locate theta first. Locate theta first, then plot using R. Okay, so locate theta, then plot using R. Okay, so like what I mean by that is locate pi over 3 first, then go 2 in that direction. So here's my coordinate plane. Okay, but it's got all these concentric rings for the different radiuses away from the center. And we'll say that like each one of these rings counts as 1. So like this first ring, that's 1 from the center. The second ring here is 2, 3, 4, 5, 6, 7, and then 8 from the center. Okay, all those different radiuses. So here's pi over 3. So any point along this ray from the pole out, right, that's an angle of pi over 3 away from that polar axis. And we're going to go 2, though. We want to go 2 in the direction of pi over 3. So here's pi over 3, and we'll count 2 in that direction. So there's 1 ring, 2 rings. And so there we are. There's our point. 2, comma, pi over 3.
Does this like completely change how equations work?
It doesn't completely change it, but there are some like different kind of properties that arise. Yes, yes. And the kinds of graphs that you're going to see will be very different, right? You know, we're used to, with rectangular coordinates, we're used to seeing like lines and parabolas and polynomials and stuff like that. With polar, you're going to see more like, what you'll see more properties of polar stuff is that like things repeat, and that they also will have like more, I'll say like a regular or symmetric design. You'll see here. We're not going to graph right now today. If you want to play around with any of your graphing calculator, you're more than welcome to. You just change your mode to polar. But today we're just going to focus on plotting points. But you'll get an idea about some of the interesting properties just from what we're about to do here in a second. So 3 comma negative pi over 6. Well, now this is interesting. To rotate negative pi over 6, if you look on your polar graph here, there are no negative pi over 6 angles. Okay? When we rotated positive pi over 3, which direction do we rotate? Counterclockwise, right? And we went pi over 3 in that direction. For a negative pi over 6, which direction should we rotate? Clockwise, and clockwise pi over 6. So where are we going to end up if we rotate clockwise pi over 6? At the 11 pi over 6. Exactly right. And so we're going to go 3 in the direction of the 11 pi over 6. So from the pole, 1, 2, 3. There's the 11 pi over 6 right there. Or sorry, the 3 negative pi over 6. Okay, so there's our point right there. Now, what if I wanted to plot 3 comma 11 pi over 6? Where would that 3 comma 11 pi over 6 be? The same location. Okay, so just stop and ponder that for a second here, right? One point, one location, right? This location right here, there are 2 different coordinates that locate that same point. Does this happen in rectangular coordinates? No. It does not, right? In rectangular coordinates, if you have a location, there's only one pair of coordinates and rectangular coordinates that locate that point. Only one. It's unique. Here, how many coordinates will locate this point in polar coordinates? Infinity. An infinite number of coordinates will locate this point. So you're going to see in polar graphs, you're going to see graphs that overlap themselves, that intersect themselves. Okay? A little crazy. All right, so that's a huge new property of polar graphs, is that polar graphs can intersect one another, or intersect themselves, I'm sorry. All right, let's go back here now to have you guys try some. So try to locate 4 comma 5 pi over 4, locate 8 comma negative pi, and locate 0, 5 pi over 3. for those of you planning on taking Calculus BC next year, you'll be seeing this again. It'll show up again. Now, obviously, we'll go beyond just plotting points and stuff, but I mean, we will definitely see this again. For those of you just taking AB or not taking any calculus at all, you won't see this.
Who teaches BC, Mr. Whitmire?
Right now, Mr. Goff is scheduled to be teaching the BC, AB and BC.
See who teaches.
He's this man right here at the center, at the polar axis of my polar graph paper
Oh,
right
so
here.
that's not you, because every day I look at them, I'm like, that doesn't look like Mr. Whitmire.
You know, it's funny you say that because every student that has both of us or knows both of us says we are the exact same person.
Yeah, that's why I thought it might be you, and it just...
That's a ginger.
I know, but it looks like Mr. Whitmire, like just enough.
Yeah.
I was confused.
Well, this is a wig.
Well, I don't
come
know,
on.
people like dye their hair, I don't know. I don't know.
So he dyed his transparent for the picture. I mean, I dyed mine transparent for that picture. So
I mean,
You could bleach it.
if you
Could.
bleach-
True.
If you bleach
Skin tone
dark
bleached it.
hair
Are they gonna
and
come out
dye
with
it
an
pink,
invisible
it'll
spray?
eventually turn
maybe
orange.
one day.
That's
I don't know, if you eat some really greasy food, sometimes it makes the wrapper invisible, you know, you can see right through that.
Ew.
Yes. Yeah. All right. So, there's a Simpsons like episode where Homer's trying to gain weight and he goes to a doctor about how to gain weight. And the doctor's like, take your food and rub it on the window or rub it on the wall. If you can see through it, that's your window to weight gain. Anyway. Yeah. So, anyway, let's plot these points here. All right, so 4, 5 pi over 4. So let's see, we'll locate 5 pi over 4. There it is right there. We'll go 4 in that direction. Now be careful here. You'll see that 5 pi over 4, the line, the ray for it, doesn't go all the way to the pole. It's not for any special reason other than if we drew all of these lines into the pole, it would be too concentrated with all those lines in here, and it would just be really messy, I think. So they just don't graph them. But still, if we're going to go 5 pi over 4, you want to count that ring. So that's 1, 2, 3, 4. There would be your point right there.
What do you do if it's like 5 pi over 4, like 2?
Like if the first number is 5 pi over 4?
2 or like 1, yeah.
If this was 5 pi over 4 and this was 2?
No, if it was 1, 5 pi over
1 5 pi over 4, then you would go, you kind of have to eyeball it here in this case, kind of thing, maybe like right there. Halfway. You could extend the ray using a pencil or something like that if you need to. 8 negative pi. So for this one, we're going to go negative pi. Now, negative means you go clockwise. So clockwise pi, well, it's still going to give us the pi. And we'll just go 8 in that direction, which is right here. And so there's 8 negative pi. And then finally, 0, 5 pi over 3. Well, if your radius is 0, where are you? You're at the pole, right? No matter what your angle is, 0, 5 pi over 3, it's at the pole. Now, questions on any of that? Yeah. Yeah, go ahead. So we've seen, yep.
So, well, this isn't related to that. It's actually just about the graph.
Mm-hmm.
It says in the notes, it says the x-axis is now the polar axis.
Mm-hmm.
But there's nothing really comparable to the x-axis. So what is the polar axis? Is it just the whole graph?
The polar axis is so when I say the polar axis, I really mean this positive part of the x-axis right here.
Oh, okay.
That's the polar axis, I would say. Just the positive part, really. It's not actually positive and negative, it's just the positive part.
So
Okay.
is it just the value for the first coordinate's value?
What is the polar axis, you mean? It's the place from which we measure our angle theta. It's like the initial side of the angle for theta, and then theta will locate the terminal side using theta. Okay, how much to rotate. Anywho, good question though, very good. So let's take a look at one more thing here. We've seen negative theta values, but we have not talked about negative r values. And you might think, well, maybe it's because it's a radius, and radiuses are always positive, so, but no. In fact, we can have a negative r value here, and we'll talk about what that's going to be like. So let me just do this one here real quick. Yes? Yeah, sure. Okay, so negative 2, pi over 4. Well, you would still do the same thing you would normally do, right? We'll rotate and locate, there's pi over 4, okay? And if we had a positive 2, we would go towards the pi over 4 2 units. But exactly right, what you were saying there, Rebecca. Since it's a negative 2, we're not going to go towards the pi over 4. We should go which direction? The exact opposite direction. So yes, we're pointing towards pi over 4, but because it's negative 2, we're actually going to go towards what angle? The opposite, 5 pi over 4. And we'll go 2 towards that one, or 2 back, 2 back from the pi over 4, or 2 towards 5 pi over 4. So there's where that angle, there's where that point is. Okay. So there's the negative 2 pi over 4. Okay, right there. Alrighty. Questions on any of that? No questions? Okay. So we'll turn the paper over here, and I just have a brief thing I want to talk about when it comes to converting from polar to rectangular coordinates. We're going to hold off on converting from rectangular to polar just yet. I think some of the homework tonight has some rectangular to polar, but we'll not worry about that right now. We're just going to do polar to rectangular. So I want to try and give you guys some time to get started on the assignment too. Okay, so converting polar to rectangular. Okay, so I'm going to draw again that little picture that I showed you earlier about how we locate a point on the coordinate plane, right? So let's say, for example, here again I've got a point with coordinates r comma theta, okay, which means then I had to rotate a certain angle theta here, and then go out a certain distance r from that pole. And so the idea is then we want to come up with the x and y, the rectangular coordinates for this. So this point, right, while we located it by turning a certain angle theta and going out a certain distance r to locate it, right, we could also go left or right and up or down to get to this point too. Okay. Now, this point here is known as the pole in polar coordinates, but it's also known as the what in rectangular coordinates? Origin, right? And so instead of turning theta and extending r to find that point here, we could instead from the origin go left or right a certain amount, right? And so that would be like our x coordinate here. And then from that x left or right amount, we could also go up or down a certain amount, and that would be our y coordinate there. Now, what kind of shape will relate all these pieces of information? And not just a right, it's a right triangle. Darn it. Sometimes I give away my answers before I say what I want to say. Okay, yes, it's a right triangle. Okay. So let's see here. So again, we're converting from polar to rectangular. So I know what r and theta are. I know what those numbers will be. And let's say I want to solve for x. So I know r, I know theta, and I want to solve for x. How could I relate these three pieces of information using what? So which one in this specific case? For r, theta, and x, what should I use? Cosine, because we have the adjacent leg and the hypotenuse there for theta. So yeah, we'd say cosine of theta would equal what? X over r. Okay? But of course we know r and theta, and I want to know what x is, so if I multiply r on both sides, I get x equals r times the cosine of theta. Right? Now let's say I want to solve for y. What would be the equation or the relationship I could set up to solve for y here? Sine, right? Sine of theta is opposite y over hypotenuse r. Okay, multiply both sides by r, we get y equals r times the sine of theta. All right, and so these are the two formulas, I guess you could say, or equations we use to find the x and y coordinate of a rectangular point given the r and theta of a polar coordinate. There's another kind of interesting relationship here too. We saw a relationship like this when we did the unit circle, right? So if you can remember back to the unit circle, what's the radius or r value of the unit circle? It's 1, right? It's the unit circle. The radius is 1. Well, if I put a 1 here and a 1 here, didn't we say on the unit circle that the x coordinate on the unit circle was the cosine of the angle theta, right? And then y was the sine of the angle theta on the unit circle? So we were essentially doing like some very basic polar graphing or polar, conversion there back when we did the unit circle stuff. Okay. So anyway, let's just convert one point here. Convert to rectangular coordinates. Okay. And let's just convert 2 comma pi, which is a polar coordinate, we'll say there, that's r, that's our theta, and we'll convert those into something with x and something with a y coordinate, right? Blank and blank. Okay. So, x is equal to, well, x equal to 2, whoops, we do r cosine theta here, okay? What's our r in this scenario? 2, right? And then what's our theta? Pi. Okay. What's cosine of pi? -1 times 2 then would be -2. So x is -2. There's our x coordinate, -2. Let's try y. Y equals r times the sine of theta. What's our r again? 2. What's our theta? Pi. What's sine of pi? 0 times 2? Still 0. And so there's the matching rectangular coordinate. Now, we can go up to our graph here and kind of like see if this makes sense in the context. Not in the context, but just see if it makes sense kind of graphically. Right? Let's imagine where 2 pi is. So going back to my little graph here. Okay, 2 pi. So locate the angle pi. There's pi. Let's go 2 in that direction. 1, 2. There's my point. Right? There's 2 pi right there. But isn't this also, if you think in like x and y coordinates, right? Here's like the y-axis. Here's the x-axis. If I go left, 1, 2, isn't that the point -2, 0? It's the same place, right? And so we get the same point. Okay, so the same. Questions on any of that? All right, then I'll give you guys your assignment here real quick. Put it up on the board. Yes. Yes.
What if it wasn't like the angle was like 3 pi over 4? Like, would you go up based on normal numbers?
So yeah, I'll talk to that in just a second. Really get this right. Okay, page 781. Numbers 5 to 7, 11, 19, 23, 37, 43. Okay? Let me get the video stopped here real quick, Joshua, and I'll answer your question.
You're the